He went blind, but he survived this kind of traumatic injury. However, Phineas Gage, Mr. Gage, poor Mr. Gage, not only did he suffer a humiliating injury, he also changed a lot of his behavior. People afterwards, the accident, noticed that he's become more irrational. He became angry with his wife. He became a bit more violent. He became very unreliable. He couldn't really plan out his day anymore, and he spent most of his day like just drinking and cursing, right? So it's a very different Phineas Gage. And so you might be saying, well, something must have happened to Phineas Gage that changed him. And what part of his brain was actually damaged was the left frontal lobes. The left frontal lobes, what's your best guess where that might be? You might think it's on the left in the front, and that would be absolutely correct. Luckily, they named it very carefully. The left frontal lobes. And so from this kind of case study and kind of further on research on what the left frontal lobe did, they kind of concluded that the left frontal lobe basically is like the executor, the thinker, the planner of the brain. That this is the place where we kind of create plans and exhibit self-control. Right? So when it was damaged, Phineas Gage kind of lost a lot of that ability and became a different person. Another example of case study is when they looked at patients with kind of unique disabilities. And then after they passed away, they died, they would do an autopsy in the brain and see whether the brain has different or damaged in some way. So this is kind of like post-mortem studies. One of the first one is Broca's area. And Broca was a researcher, a brains researcher, who had a patient who suddenly lost the ability to speak. All of a sudden, this person, Tan, couldn't speak anymore. And so Broca was very interested about what happened. And so after this patient's death, Broca went to the brain and found that there's damage, again here, in the left side, this is the left side, around here, behind the left frontal lobes, the parietal lobes. And he concluded that that must be the place in the brain that controls spoken language, right? That's one kind of aphasia. Aphasia means the inability to recognize kind of words and ideas. So in this case, the patient there just couldn't speak anymore. Another researcher similar in Wernicke's, Wernicke had a patient that suddenly couldn't read and recognize text anymore, right? So when looking back into brain damage, it was somewhere further back in the left side of the brain, what he called Wernicke's area. That's great. Back at the time, there's real estate that any researcher could just name that part of the brain after them. But this is the kind of idea that using people with brain damage and post-mortem data, we could kind of find out where the damages are and why that area, that kind of deficit occurred. I'll give you one more example with case studies, which is that of split brain patients. And we're going to talk about that more later. And this is a very fascinating group of people. Sometimes people get epileptic seizures when their brain the left and the right side kind of crosses wires, and so generates excessive electrical kind of chemistry imbalance. You've probably seen epileptic seizures before, and that's when people start shaking and they convulse, and they can't, and it's like they're being electrocuted alive in their brains. And so one thing that scientists have done to reduce these seizures is to kind of cut off the mass of tissues between the left side and the right side of the brain. Therefore, I'll draw a quick. This is looking at the front here. This is the left side and the right side of the brain. There's a mass here called the corpus callosum that really is the kind of the connector of the two sides of the brain. That's how they communicate with each other. And so it's actually possible to sever all of this, cut it down, and so the left and the right side of the brain can't communicate anymore. For these epileptic patients, it was actually a godsend. They would stop having seizures. Early researchers are afraid that, well, if the left side and the right side can't communicate anymore, what's going to happen to this person? And they found that on most function, these people function perfectly fine, and they're able to see that there was the cross-brain lateralization still occurred. That is, the right side of the brain controls the left side of the body, and the left side of the brain controls the right side of the body.